On a problem like this, it's best to understand that all regular polygons act the same. And so I've drawn a circle with a square inscribed in it, and then a circle inscribed in the square, which is what we're doing with an 18 gun. And so the first circle is circumscribed about the square, and if we look at the center, from the center of the square to the circle is the radius of the circle, but it's also what we refer to as the radius of the square from the center to a vertex. And then of the inscribed circle, this line right there is the radius of the inscribed circle, but it's also the apothem of the, or A as we refer to it, of the square, which turns out in a square's case, it's actually half the side length, but it's still what's referred to as the apothem. So in this problem, we know that the radius of the circle is the big circle is the same as the radius of the 18 gon, and then the apothem of the 18 gon is the same as the radius of the small circle. So we could think about it as radius big equals the radius of the 18 gon, and then the apothem 18 gon equals the radius of the small. And so when we start this problem out, it tells us that this big circle has an area of 80 pi. Well, using pi r squared for area of a circle, we can easily divide through by pi and get r squared equals 80. And so when we take the square root of both sides, you get r equals, well, square root of 80, which is the same as 4 root 5. So now we know that the radius of the big circle is 4 root 5, which means the radius of the 18 gon, which we're just going to draw a section of, is also 4 root 5. And so the radius here is 4 root 5. And then, because it's an 18 gon, we can find the interior angle. The way I like to do it is to think about the external angle here. All of the external angles add up to 360. So 360 divided by 18 is 20. So if this is 20, then this is 160 because it's a straight line, and the angle inside here is just half of the angle of the polygon. An 18 gon has a 160-degree angle, and so this triangle has an 80-degree angle. Now we start using our trig to find out the apothem of the 18 gon. Because ultimately, what this problem is asking is, what is the area, which should be an A, inside the 18 gon, but outside the smaller circle? So we want to find the area of 18 gon minus area of small circle. So to do that, for the area of the 18 gon, we use the 1/2 apothem times perimeter minus pi, and then the small radius squared. But the A and the R are the same. So how do we find the A, which turns out to be the R of the small circle? We use trigonometry. 80 degrees, A is the opposite, so it's going to be sine of 80 equals A over 4 root 5. So then you're going to type in 4 root 5 times sine into your calculator, and you're going to get something, and I'm going to put a bunch of decimal places because I like to be as exact as I can be, 8.808,388, and that's 6 decimal places, which is plenty. So that's the apothem, and so we found the apothem here. We've also found the radius, so all we have left to find is the perimeter. Well, the perimeter is going to be x, which is half a side length, times 36, because there's 36 half a side lengths in an 18 gon. 18 times 2 is 36, there's 2 per side. So we do the same calculation, except now we're doing the cosine of 80 equals x over 4 root 5. And so we're going to type in 4 root 5 times cosine 80 into our, and that gives us x equals 1.553165. And so now we know everything we need, because you're just going to do 1/2 times the apothem, which is this value, times the perimeter, which is going to be 36 times this. So I'm going to put in the 36 times the x, and then minus pi times my 8.05 or 8.808 squared. And so now I just go through and I type all of this in to the calculator. You can pause the video if you want to type it in yourself. And that gives me this right here, after plugging those numbers in, gives me 2.8 5, and we'll just go ahead and round to the nearest 100th. It's 5.05, and that rounds up to 2.51. So the area inside the 18-gon, but outside this smaller circle, is going to be 2.51. Again, the key to these problems is understanding these relationships. And sometimes the easiest way to understand that relationship is to consider the square, because you can really see it, or maybe a triangle. And then it always comes down to being able to create this type of diagram, which is always the same, with the radius of the polygon, the apothem, and the x, finding the angle, and then using your trigonometry to get to a solution.